Hello everyone, in this video we're going to talk about the CPU, how it works, the different parts of the CPU and how it interacts with the rest of our computer. So to start off with, CPU is short for Central Processing Unit, and it's one of the main parts of our computer. The CPU is the part of our computer that actually does all the work. It does all the calculations. So when we talk about the CPU, there's three different stages that it goes through. The first stage is fetch, then the second stage is decode, and the final stage is execute. So when we talk about our CPU, we can't talk about a CPU without including RAM or memory. So when we want to go and execute something, it has to be stored somewhere. So this could be stored in a hard drive, and then when it gets retrieved from the hard drive, it's loaded into memory. And then from memory, it's loaded into the CPU, and then the CPU does whatever calculations needs to be done. So to start off with, our CPU needs to fetch data from memory. So we'll draw an arrow connecting the CPU to our memory, and what this arrow represents is a combination of different wires that connect from our CPU to our memory. It's just a bunch of wires that connect our CPU and memory, but we call these bunch of wires a certain name, and the name that we call them is called an address bus. Now the reason we call it an address bus is because over here in memory there's loads of small little locations. So these locations are called memory addresses. We're going to cover a different video where we're going to go in depth into memory. This video is mainly covering CPU, so I'm not going to go too deep into the detail, but that's why we call it the address bus, because the CPU is accessing the address of memory. So for the CPU to keep track on what memory location it's at, for example, imagine this is memory location 0, this is memory location 1, and this is memory location 2. So if we start off with 0, how do we track that we're on 0? How do we know that 1 is the next one that we're going to? So the way the CPU remembers where its location is using this thing here, and this is called a program counter, or we're represented as PC. So PC will hold the next address that we have to visit. So we've talked about our address bus so that we can access whatever memory location we want in RAM. Now we need to talk about our data bus. So a data bus is exactly the same thing. It's a bunch of wires, and these bunch of wires collectively we call our data bus. And the reason why we need a data bus is to transfer data from the CPU to the memory and from the memory to the CPU. So if I give you an example, imagine we have our memory location here, which is 1, and imagine that the memory location 1 has the number 6 inside it. It's a little bit small, but I hope you can see it. So we have the number 6 included in our memory. We want to pass the number 6 from memory to the CPU. So we're not going to use the address bus, because if you look at this arrow, this is a one-way flow. It's a one-way flow from the CPU to the memory, while the data bus can flow from the CPU to the memory and vice versa, from the memory to the CPU. So we would send 6 to the CPU via the data bus. So this is a more in-depth look at our CPU. So we can see we've got our CPU and we've got our program counter up in the top right corner here. And then we've got our fetch, decode, execute. So these are three separate parts of our CPU that's called individually for each program that has to be executed. So the fetch does what it might suggest. It fetches the memory address and the data from the CPU. After fetch has been called, that has to be decoded. After it's decoded, it's then executed by the CPU. So if we run through an example of this, if we want to fetch something, we might want to fetch the number 6 here from memory location 1. So when we fetch this, we want to do something else with 6. We might want to add 1 to it. So I've redrawn out my RAM, so you can forget about the one up here. And if we take a look at it, we can see the address on the left hand side and the values on the right hand side. So we can see with our addresses, we start at 0 and we finish at 7. And then for our values, we can see we've got some keyword and then we've got a number. And these little dashes here, this just means that there's nothing contained in memory or at that memory location. So we can see, for example, in 5 and 7 and 0, there's no instructions, there's nothing to be executed. So when we start off this program, we start off at counter 1 because that's where our first instruction is. So we load 6. So if you look at load, add, store, jump, these are all keywords. So if you've ever used an assembly language before, you'd be familiar with these. And then after the keyword, there's a number after all of them. So these numbers here represent a memory location. So if we look at this first one here, it says load 6. So if we want to load 6, we have to go to memory location 6, which is here, and we want to load the contents of memory location 6, and in this case it's 6. So then what we'll do is we'll increase our program counter to 2 because it was 1. Now we want to add, and then we want to add the number 2. Keep in mind, for each one of these steps the value will be fetched, decoded and executed, and then we move on to the next one. So after we've added 2 to 6, we then want to store it. So where do we want to store it? We want to store it in memory location 6. So this will actually change from 6 to 8. And then we can see in our next instruction we have jump to 1. So jump to 1 is jump to memory location 1. So we come up here again and we go and load 6. So this time we're going to memory location 6, but we're not going to load the value 6, we're going to load the value 8. And then when we want to add to 8, we want to add the number 2. So 2 and 8 is 10. So then we move on to our next step. We want to store it at memory location 6. So 8 will be overwritten with the number 10. And you can imagine this will keep looping through all the time. So if you've ever used loops in any programming language, if you've ever used a for loop or a while loop, this is the basic idea behind them. With a loop, it executes over the same instructions over and over and over again, and that's what we're doing here at a very small, simple scale, but that's what we're doing. In our next video, we're going to take an in-depth look at memory. So if you like the video, give it a like. If you're interested in this type of content, hit the subscribe button to be informed of new videos.